Welcome to the Sun Today for the 8th of February 2022. The question we're taking a look at today is, where are all the big flares? Before we discuss that question, let's take a look at the status of the sun at the moment. This is the report I put on my Twitter channel first thing this morning. You can see from the first panel here, this KP index, that geospace is quieted down quite a lot compared with the last few days worth of high levels of activity. Panel 2 shows that the official sunspot number has reduced as well. It's down around about 70, which is still quite high for this time in the cycle. Panel 3 shows you where the sunspots are. We have several numbered regions. Active region 2942 is about to go over the west limb, so we'll lose it by tomorrow. 2940 is stable, as is 2939. 2941 seems to be growing slightly, at least in sunspot number, and is also stretching out as the differential rotation of the sun tries to rip it apart. We have three very small new regions marked here by dashed circles. Panel 4 shows the GOES X-ray background, and you can see we've had no major flares for the last 3 days. Last but not least, we have 59 days since the last spotless day. We've had a lot of flares over the last few months. In 2022 alone, we've had over 200 C flares, but only 6 M flares and no X flares. Now, with that many C flares, you'd expect something like 20 M flares and 2 X flares, but that isn't the case. We've also had some very large sunspot regions, very strong and very large and very dynamic, but no big flares. Again, the question comes down to why. There are basic rules of thumb as far as flares are concerned. The best way to predict a big flare is to just had one, because they tend to come in bunches. Big flares occur on rapidly growing regions, so when you see a new sunspot region emerging on the sun and growing very rapidly, that's also a good indicator for flares. Another indicator is whether the sunspots are dynamic, whether they're moving around or spinning, because that winds up and stretches the magnetic fields and puts energy into them, which can be released in the form of flares. There is one piece of mythology that says that big flares mainly occur during the decay phase of a cycle, and we'll take a look at that in a minute. Also, there's some indication that big flares occur in the decay of an active region, when the region is falling apart. I think that is less common than when it's growing. And another thing says that big flares are always associated with coronal mass ejections. This isn't 100% true, but it's a fair guess that when a large flare goes off, there'll be a coronal mass ejection associated with it. Let's take a look at the progress of solar cycle 25 so far. This is a plot of the number of flares in a day that we've observed using the GOES X-ray monitor. Solar cycle 25 started in January of 2020, and you can see for the first few months of the cycle there were no flares at all. The black lines here are C flares, and they're much more common, of course. The red lines that you can just see if you look carefully are the M flares, and I've marked the timing of the 2 X flares that we've had so far. The number of these C flares has been steadily building up over the months, and we've had some days where we've had over 30 C flares in a day. This usually happens when the X-ray background rises to the near C1 level, and then it only requires a small brightening to produce a C flare. So it's somewhat of a cheat to the system. Well, how does solar cycle 25 compare to solar cycle 24? Here I'm looking only at X flares. These are the really big flares, and there were 49 of them during solar cycle 24. And they distributed themselves in time like this. Now, solar cycle 24 started in January 2009, and for the basic first 2 and a bit years, there were no X flares at all. Then there were relatively small numbers of X flares, and culminating in 2 large X flares right at the very end of 2015. And after that, there were no X flares at all, which is rather strange. And so we've went basically 5 years without having an X flare until the new cycle came along. So let's compare what solar cycle 25 is with solar cycle 24. So solar cycle 24 is everything to the left of that line. Maximum for solar cycle 24 was in April of 2014. Here you can see that most of the X flares occurred before maximum, but the two biggest flares occurred after maximum. Well, where is solar cycle 25 on this scale? Well, what I've done here is I've put a scale across the top, which is the timing for solar cycle 25, and marked in purple the two X flares that we've had so far. And you can see they came much earlier in the cycle than they did the equivalent flares for solar cycle 24. In fact, we could go for most of 2022 without having another X flare, and solar cycle 24 would be equivalent to solar cycle 5. However, that's unlikely. I think we're going to get a few X flares in the later part of this year. So it looks as though solar cycle 25 is well ahead of solar cycle 24. I have a rule of my own for solar flares, which I call the rule of 10. It says that flares that are larger than 10 times the X-ray background are unlikely. So if you have a C background, then a flare that's 10 times larger than that is much less likely than anything within a factor of 10. So here's your factor of 10. I've drawn the background as it is at the moment, and that would say that we're not likely to get any flares that are bigger than the background shown here. There is an exception to this rule. The exceptions are from flares that are behind the limb, and so you can get a large flare from a region behind the limb, and that would break the rule. So the question remains is, why aren't we getting so many big flares at the moment, even though we've had large regions and lots of activity, smaller flares? Well, I think it's the lack of the wind-up of the magnetic field. This is how solar cycles work. If you look on the left here, this is this magnetic configuration for solar cycle minimum. You have a basically simple dipole field with field coming out of the northern pole and going into the southern pole. And the surface lines, those are the dark lines on here, are relatively parallel and simple. But the sun rotates differentially. It rotates differentially on the surface, with the equator going faster than the poles by quite a large margin, and also with depth. So these magnetic fields, which are frozen in the solar plasma, start getting twisted and distorted, as shown in the second figure here. And the longer it goes on, the more twisted and contorted they get. When you twist or stretch a magnetic field, it puts energy into the field, and it's that energy that's released that produces a flare. So by the time you get towards maximum, the figure on the right, the magnetic field is very, very spun up and has a lot of energy in it. I don't think we're quite at the stage yet where we have enough energy in those magnetic fields to produce a large number of big flares. That will come later. So what conclusions can we draw from all of this? Well, solar cycle 25 is way ahead of solar cycle 24. It is much more active and therefore is liable to be a larger cycle. Predicting flares and CMEs, at least in the short term, is a mug's game. You're going to be wrong most of the time. The rules of thumb that I laid out are a good guide, but they're not set in concrete. They can be wrong. So I think the only thing to do is to keep calm, sit back, and enjoy the show, which will be featuring for the next several years as the sun gets more and more active. So until next time, stay safe and goodbye.